This is my fourth example of a ratio test, and this one is a doozy, man. This one stumped me. I got it. Like, I know I did it right, but, like, when I came across it, I was like, dude, this is actually hard. So, here's what the problem is. So, it's the summation from n equals 1 to infinity, but nobody really cares about this, of our 5 to the n, x plus 1 to the n, all over 2 to the n plus 1. So this whole thing here is a sub n, if you don't remember. And then what you do when you've got the ratio test, you take the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. And for this problem, I am going to find the open interval of convergence again. So this has to be less than 1 for it to converge. Less than 1. So this is what I have to do here. So, what's doing? Okay. I need to show you the actual problem. So, let's do it. So the limit n approaches infinitar of, stop trying to act cool in your math videos, Josh. 5 to the n plus 1. Yeah, that's all fine and dandy. 5 to the n plus 1. X plus 1 to the n plus 1. All over. 2 to the n plus 2. And that's multiplied by the reciprocal. Because, yeah, good times, because you're dividing by a sub n, and a sub n is this. So I'm multiplying by like you flip it upside down and you multiply by it. So this is just being multiplied by 5 to the n, x plus 1 to the n, and then this is 2 to the n plus 1. Alright, let's do it. So now it's the limit as n approaches infinity of the absolute value. So I've got 5 to the n times 5 to the first power over 5 to the n, which means the 5 to the n's cancel. That's cool. So I'm grouping the terms, yeah. So I grouped the 5's and the 5's. Now I'm going to group the 2's and the 2's. So I've got 2 to the n times 2 to the first power, and then I've got 2 to the n times 2 squared. So then that means the 2 to the n's will cancel. And then this guy will cancel this guy, so I've got a half now. So I've got 5 halves. And now the x plus 1 to the n, and x plus 1 to the n plus 1. So this is the same as x plus 1 to the n, and then this is being multiplied by x plus 1. I know that's really small, so it's x plus 1 to the n. So these guys cancel, so I'm left with x plus 1. So if you don't remember what to do, you pretty much bring everything outside of the absolute value that's not dependent on n. So you got now you've got 5 over 2 times the absolute value of x plus 1 times the limit of as n approaches infinity of what? Of what? See, that's the problem. You're like, well, what am I taking the limit of? Everything's been taken out. And the way to come around about this is to say that this is technically n to the 0. No matter what you plug in for n here, it's always going to be 1, because anything to the power of 0 is 1. So, yeah, that's the trick. Basically, at the end of the day, this is going to approach 1. So this whole thing is going to go to 1. And then that means your answer is 5 over 2 times the absolute value of x plus 1 is less than 1, which means that the absolute value of x plus 1 is less than 2/5. Cool. Now, let's find the open interval of convergence, shall we? So, for this to be less than 2/5, let's say that x is greater than 1. If x is greater than or equal to 1, that means that x plus 1 is less than 2/5, which means that x is less than 2 over 5 minus 1, and that means that x is less than 5. So I multiply top and bottom by 5, which that's 2 minus 5. So this is minus 3/5. Alright, so that's one of my points for this to be convergent. Now, what if x is less than 1? Well, that means that negative of x plus 1 is less than 2/5. Sorry, I had food, by the way. In case you can hear me almost burping every 5 seconds, I had food, dude. I had like a veggie Whopper from Hungry Jack's, and dude, that's like my favorite burger of all time. I've actually got a real problem. Anyway, negative x minus 1 is less than 2 over 5. So now, negative x is less than 2/5 plus 1, which is the same as 2/5 plus 5 over 5, because this is 1, yeah? Negative x is therefore less than 7/5. But I don't want negative x, I want x. So I multiply, I divide by negative 1, yeah? Which means that x, when you divide by a negative in an inequality, you flip the sign. So now x is therefore greater than negative 7 over 5. Which means now that my open interval of convergence is negative 7 over 5 is less than x is less than negative 3 over 5. So basically, if I plug in a value that's in this range, this series at the very top will converge. And that's the end of the problem. Thanks for watching. See ya.